And there's two ways that we can lower the time spent on defects. We can prevent more defects so that they don't happen in the first place, or by prevent, we're going to basically find them super early, super early. And then we're going to find and fix defects quicker, the smaller set that actually does escape out to our customer or even out to product management. So for preventing more defects, we're going to put in place static analysis, testing, and formal inspections. We have plenty of other content diving deep into each of those. I invite you to go to our webinar archive. And for finding and fixing defects quicker, we're going to make the work more visible and have a process that inspections can layer on top of very easily. We're going to implement automated DevOps practices, so we have a very short cycle time so that any defect that does slip out can be fixed much more quickly. And then we're going to add real-time monitoring and self-diagnostics so that our system, while it's running in production, is helping us find issues and alert us in real time so that we find and fix those defects a lot more quicker as well. So let's dive into making work visible and where to layer on some of these formal inspections. So if anybody has read about the DevOps movement, which is now 13 years old, the first way of DevOps is systems thinking or making work visible. Okay. And it starts with the tracking system by which you actually enter all your work. What kind of ticket system do you use, whether Azure Boards, whether Jira, any kind of project management system, and all of them have kind of a board visualization where you move cards from the left to the right. And what's important is for each of these columns to be a stage in your software development lifecycle. And the Agile movement has taught us that instead of large batches of software features moving across this process together, we should drive down to a batch size of one and iterate on that so that we have one feature or one change where we can think about the concept, think about the requirements and the business objective, then move it along to user experience design and think about how is a person going to use this change? What are they going to experience? What's it going to look like? And then move it along to technical design and make architectural determinations or design patterns or choose some of the libraries that you might use to implement it. And then move it along to test design, which kind of gives us our definition of done for that particular feature or change. We break it down into its piece parts and we determine how many exception paths we want to support, what the real scope of it is. And now with those 4 decisions made, we can send it on to the people who are doing the programming. And of course, those people participate upstream as well. But now it's time to actually write the code. And after the code is written, we functional validation at the team level to make sure that, okay, it does work. Then we send it on to product management so that they can validate the user experience, so that they can make sure that it does work the way it was intended to work. And then we move it along to release validation, get it ready to send off to the customers. And then, of course, it's released to the customers and it's done. And so requirements inspections go very well between conceptual definition and user experience design, whereas whoever is assigned to determine and writing down what we expect the user experience to be, how it should look, how it should behave, if we have a checklist for completeness of requirements for that particular feature, not a whole bunch, but for that particular feature, well, now we've formalized the inspection. And in test design, if we have a checklist for what it means to have a complete design from a UX and a technical perspective, well, now we've added some formality to that inspection. And then in functional validation, if we have a checklist by which to look at the code that was used to make that feature happen, well, now we've added some formality to the code inspection, and we're getting the benefits that Capers Jones has determined in the research, the benefit of formal inspections.